Hi, I am Siddhant and I'll be your interviewer today. Let's start with a basic question. What's the difference between R square and adjusted R squared?
Of course, R squared is a statistical measure that actually represents the proportion of the variance for the dependent variable that's explained by the independent variables in a regression model. Now this actually ranges from 0 to 1, where higher values indicate a better fit. However, R squared doesn't account for the number of predictors in the model, which means that it can be misleading if you add more predictors even if they are not significant. Now, adjusted R squared on the other hand modifies the R squared by including the number of predictors in the model, providing a more accurate measure. Now, this actually adjusts the statistics based on the number of predictors, making it more reliable for comparing the models with different numbers of predictors. And if you can add a predictor that doesn't improve the model significantly, adjusted R squared can actually decrease, indicating that the new predictor doesn't provide value.
Could you clarify the differences between bias and variance in context of various machine learning models?
Certainly. Variance refers to the model's sensitivity to small fluctuations in the training data. Now, a high variance model pays too much attention to the training data, capturing noise along with the underlying patterns, which can lead to overfitting. This actually means that the model will perform well on the training data but poorly on the unseen data. Now, on the other hand, bias actually measures the error introduced by approximating a real-world problem, which may be complex, by a simplified model. Now, high bias models are too simple, failing to capture the underlying trends in the data and leading to underfitting as well. Now, in essence, a good model seeks to balance bias and variance to achieve low overall error.
Moving on. What do you mean by standard deviation and how is it relevant in machine learning?
Standard deviation is a measure of the amount of variation or dispersion of a set of values. Now, this can actually be calculated as the square root of the variance, and it also provides a sense of how spread out the values in a data set are around the mean. Now, in machine learning instead, standard deviation is crucial for understanding the distribution of the data points, which can inform decisions about data pre-processing and feature scaling. For instance, standardization, which transforms data to have a mean of 0 and a standard deviation of 1, is a common pre-processing step to ensure that the features contribute equally to the model.
What is median and what is its significance in data analysis?
The median is the middle value in a sorted list of numbers. Now, if the list has an odd number of observations, the median is the middle number. Now, for example, if it is an even number, the median is the average of the two middle numbers. The median is a measure of the central tendency that is particularly useful when dealing with skewed distribution or outliers. But unlike the mean, which can be heavily influenced by extreme values, the median actually provides a more robust measure of the center of a data set.
What do outliers represent in a dataset and how do they impact the machine learning models?
Outliers are data points that significantly differ from the other observations in a data set. Now, this can be due to variability in the data or measurement errors or other factors. Now, outliers can have a substantial impact on the machine learning models by skewing the results and affecting the performance. Now, again, for example, in a linear regression model, outliers can distort the estimation of the coefficients, which can actually lead to a less accurate model. Therefore, it is very important to identify and appropriately handle the outliers, which might involve removing them, transforming the data, or actually using robust to outliers.
What is overfitting and why is it a concern in machine learning?
Overfitting happens when a machine learning model learns not only the underlying patterns in the training data, but also the noise and also the random fluctuations. Now, this can result in a model that performs exceptionally well on training data but poorly on an unseen data. And overfitting is a concern because the model lacks generalization, meaning it won't make accurate predictions on real world data. And in order to avoid the overfitting, it is very important to actually use techniques such as cross-validation, regularization and pruning, and to ensure the model is not overly complex relative to the amount of training data.
Now moving on to evaluation metrics, what is ROC AUC curves and how are they useful?
The receiver operating characteristic curve is a graphical representation of a binary classification model's performance. Now, this plots the true positive rate against the false positive rate at various threshold settings. The area under the ROC curve quantifies the overall ability of the model to actually distinguish between the positive and the negative classes. A higher AUC value indicates better model performance, and the ROC AUC curve is particularly useful and helpful when dealing with imbalanced data sets, as it provides a more comprehensive evaluation of the model's performance across different thresholds.
What are the various strategies to overcome overfitting in machine learning?
There are several strategies to mitigate the overfitting. First one is cross-validation, wherein you use techniques like k-fold, and this is to actually ensure that the model performs well on different subsets of the data. Second would be regularization, wherein you apply regularization techniques such as L1, which is lasso, and L2, which is ridge regularization, which adds a penalty for larger coefficients, discouraging the complex models. Third would be pruning. So now in decision trees, pruning involves removing parts of the tree that do not provide power in predicting the target variables. Next would be reducing complexity. So we need to simplify the model by reducing the number of features or selecting a less complex model. Then would be ensemble methods. So use ensemble methods like bagging and boosting to improve the generalization. And last would be more data, wherein you increase the size of the training data set, which can actually help the model to learn the underlying patterns better without actually overfitting to noise.
Could you please explain what feature engineering is and discuss some of the common techniques?
Feature engineering is the process of creating new features or modifying existing ones to actually improve the model performance. Now, most common techniques would include scaling, which is normalizing or standardizing features so they contribute equally to the model. Then would be encoding categorical variables, wherein you convert the categorical variables into numerical format using techniques like one-hot encoding or label encoding. Next would be creating interaction features, now wherein you combine existing features to capture the relationships between them. Then would be binning, so wherein you convert the continuous variables into discrete bins to actually reduce the noise and handle the outliers. Then would be handling missing values, wherein you impute the missing values using mean, median and mode, or more advanced techniques like k-nearest neighbors.
Moving on to some of the foundational concepts, what is the central limit theorem?
The central limit theorem is a fundamental statistical principle that states that the distribution of the sample means will approximate a normal distribution as the sample size becomes larger regardless of the population's distribution. Now, the reason why the theorem is crucial because it actually allows the statisticians to make inferences about population parameters using sample data. While in machine learning, the CLT justifies the use of normal distribution based methods and helps in understanding the behavior of the estimators and the test statistics.
Could you please differentiate between the z-test and the t-test, and where are they used?
Z-test and a t-test are both used to determine if there is a significant difference between sample means, but they are used in different contexts. Z-test is used when the population variance is known or the sample size is actually large. Now, it relies on the normal distribution. And t-test is used when the population variance is unknown and the sample size is very small, and it relies on the t-distribution, which accounts for the additional uncertainty which happens due to the small sample size. Now, both these tests are very important in hypothesis testing, which actually allows us to make inferences about the population based on sample data.
In what scenarios would you recommend using an ANOVA?
ANOVA is used to compare the means of 3 or more groups to see if at least one of them is significantly different from the others. Now, the reason why this is useful or where it is useful is in experiments where you have multiple factors and want to understand their individual and combined effects on a dependent variable. Now, for example, in testing different teaching methods, ANOVA can help determine if there are significant differences in student performance across the methods. Now, it's preferred over multiple t-tests to actually avoid increasing the type 1 error rate.
What are the key underlying assumptions in a linear regression model?
Linear regression relies on several key assumptions. First would be linearity, wherein the relationship between the independent and the dependent variables is linear. Second would be independence, wherein observations are independent of each other. Next would be homoscedasticity, wherein the residuals have constant variance at all levels of the independent variables. Next would be normality of residuals. Now here the residuals are normally distributed. Then would be no multicollinearity, wherein the independent variables are not highly correlated with each other. Violating these assumptions can actually lead to biased or inefficient estimates, making it important to check these assumptions before relying on the model's output.
Can the coefficient of determination, or R2, ever be negative? If it is negative, what does that indicate?
Yes, R2 can be negative, but this usually indicates a poorly fitted model. Now R2 represents the proportion of variance explained by the model compared to a simple mean model. Now if R2 is negative, it means that the model is performing worse than the mean model, suggesting it fails to capture the data's trend and is essentially providing worse predictions than just using the average of the dependent variable.
Could you please explain what pruning is in context to machine learning?
Pruning is a technique used in decision trees to remove parts of the tree that are not necessary for predicting the target variable, thus simplifying the model. Now there are two main types. First is pre-pruning, wherein it stops the growth of the tree early based on criteria such as maximum depth, minimum samples per node, or maximum number of leaves. While post-pruning is in which you remove the branches from a fully grown tree, often using cross-validation to determine which branches to prune. Now pruning actually helps reduce overfitting and making the model more generalizable to unseen data.
Lastly, in support vector machines, what do support vectors actually represent?
Support vectors are the data points that lie closest to the decision boundary in a support vector machine model. Now these points are critical because they define the position and the orientation of the hyperplane. The support vectors are the most influential data points in the training set, and the SVM model aims to maximize the margin between these points and the decision boundary. Now this maximization actually helps to improve the model's robustness and the generalization to new data.
Before we come to a conclusion in this interview, do you have any questions for me?